All right. Good morning, everyone. Today is Wednesday, and we have a little talk show, part of the MODSIM webinar. And today with me, I have two other hosts, two other guests, two hosts to talk. Neha and Bintek. We are sitting in the office next to each other, but for this show, we actually behind the camera. So today we do a little bit introduction about MODSIM. Okay, I work in the cat industry for quite some time, and about like 25 years ago, I was stationed in North America. I was stationed in Boston, and I visited a customer in the state of Pennsylvania. And that customer used a 3D tool to design a blow mold. You know what is the blow mold? The blow mold is the mold that to make plastic bottle, PET bottle. So it's very simple. It doesn't have like the traditional injection mold. It's only two sides, and most of the time two sides are identical. So the mold just open, close, close. And then when it closes, we put the plastic inside, and then we push the air, so it will blow the plastic, and then the plastic will adhere to the shape of the mold. And then when it's opened, you get the bottle drop out. So the cycle of those blow mold is about 15 seconds. So that's means every 15 seconds, you're gonna make one bottle. And they make bottle for Coca-Cola and other beverage company. They look at the tools to help them to cool down the mold faster. It's go from 60 degree to like 40 degree. And then they realize that they do a lot of experience. And then if they can go from 15 seconds and then go down, cut by another 3 seconds, go down to 12 seconds, it's a lot of profit for the company. Because instead of making 1 million of bottles per day, they can make 1,200,000 bottles per day. So they look at for tool that can help them to have a better design so they can cool down the temperature faster. So that is back in the 90s. And then during that time, people also talk about concurrent engineering, where we can do a lot of things together at the same time.
Hey, Ba Thong, that was a nice story. You mentioned something. Yeah, you mentioned something on concurrent engineering. Can you explain what is that, so that it's understood by the wider audience?
Okay, right. So what is concurrent engineering? This is the concept that we have back in the 1990s. Early than this, most of the time people will do the task sequentially, so one after another. So you design it. After you finish the design, and then someone will take the design and probably will do the simulation. So after they do the simulation, they will start to finish the simulation. They will send it to the CNC machine, and then they cut the mold, cut the parts, and after this they will do the testing. So the whole cycle is actually very, very long. People think that with the 3D parametric design, they can anticipate a little bit. That means when someone not yet complete the design, someone else can take the model and start to set up some condition for the simulation. And then maybe they can run the first round of simulation. And when the design is already completed, then they can do the final simulation. And at the same time as well, before they finish the simulation, someone can start to prepare the tooling, and then they can start to do the setup. They know actually the overall dimension of the parts, so they can do all the setting on the jig and other things. And they're just waiting for simulation to be approved, and then they will go for the machining. So that is the concurrent engineering. That means you can have the tasks that overlap a little bit, so they can reduce the overall time of product development. So they use, they use simulation, but simulation has many meanings. So what do you think, Neha, the best meaning for simulation?
That's a good question, Ba Thong. The story that you just told, that is one of the values of simulation. But another thing that I could think of when we talk about simulation is, normally when we do product development or product design, we always do some lab test, right? But those lab tests, we if the product doesn't pass certain specification or certain requirement, we see some failure happening to the product, right? So during the test, we just see that this certain product has failed under certain criteria, but most of the time we don't understand why it has failed, what was the reason behind it. So for me, the actual value of simulation comes, it tells you why some failure has happened, not just what has happened because of certain scenario or certain loading condition or certain and any other kind of scenario during your service. So that is the main value I see. Then when you know the reason that this product has failed because of these reasons, then you can actually focus in that area during the design modifications. And instead of wasting time and doing some trial run, you can focus on the whys of the failure, and you can modify those area and make it more robust. So that's the value I see. Do you think that's yeah?
So the simulation part of this is to help us to understand why in certain condition the part fails.
That's right. Yes.
Okay.
Yes.
And that will help us to understand how the part can be used, and then we can improve the design, right?
Correct. Correct. Yes.
Right.
You can improve the design knowing why it has failed.
Okay.
Oh, Biantek, I think you're saying something, but you're on mute.
Yeah.
Yes.
In fact, you want to say something, but you're mute.
Neha, you are mentioning
Your
the
camera
phase
is
that
off.
we. Oh, sorry.
Yeah.
You mentioned that simulation can help us to find out why it failed. So why it failed, meaning that you try to prevent it from failing, is it?
That's right. Yes.
There's a logic I can think of.
Yeah,
But I want to counter offer
sure.
another value. So, I have this experience that I got this Samsung TV, and the warranty is 3 years. And before 3 years warranty came up, it failed 1 month earlier. That means 2 years and 11 months it failed. So within warranty period, so I get Samsung to replace the new one. And now I'm using the Samsung product until now, coming to 10, 11 years already.
Wow.
So actually, this is, I believe they don't do any simulation, maybe. They should use a simulation to make sure their product fail right after the warranty period 3 years.
That's right. That is one of that. Yes, yes, you're right. So that will be another design criteria for them, that if they are giving some lifetime for a product, then they will make sure that it doesn't fail within that period.
Right.
So
a good design. So a good designer should able to use a simulation to make sure it fail after the warranty period. The best is 3 years plus 1 day.
Yeah.
It fail.
Yes.
Yes, just after that,
Yes.
maybe.
That's the best. Recently, I bought a home appliance. I will not tell you the company, but I know that company they don't use any of Dassault System product for design. And I bought it in January and guaranteed for 12 months. But then 4 months, it's broken. So I have to bring it to the service center and go to the service center because the part is very compact. It's a home appliance thing. And they say, okay, we don't repair because likely it's certain part inside. So open it, they will break everything. So we're gonna send to you a new part. And actually I'm supposed to receive by today, that's new part. Think about this, yeah, when you don't do it well, you have to replace the part for the customer. Not replace the part, replace the product for the customer. And you have to send out the new parts and the shipping fee and everything else. That can be very, very costly for the company. And if you want to give the customer the good user experience, yeah, you can make sure that if it's broken, it's only after the guarantee period. That's why recently, on top of the concurrent engineering, people do a little bit more than this. That means they not only do the design and the test, but they keep looping the design and simulation. So they will design, they simulate, and before they actually testing, they can come back to the design and simulate, come back to design, simulate again. So there's create a loop between design and simulation. And that is the we call it the concept of MODSIM. And then with DS, with Dassault System, we have this new MODSIM promotion that we would like to introduce to all of our partners in AP South.
Do you want to tell what are the roles included in that, Ba Thong?
Okay, so the roles that involved with the MODSIM are SLL, SFO, FMK, MDG, and MES.
Okay.
Wait. Can you repeat again?
SLL, SFO, FMK, MDG, and MES.
Remember what is all this?
You don't know? Okay. Too fast for you, right? Too many trigrams, right? Yes. So come back and join us on Friday, about the same time. And then I'm not an expert on simulation. On Friday, I will get the expert on CATIA and the expert on Simulia. They will go more in detail what is MODSIM and what is SLL, SFO, FMK, MDG, MES. So come back on Friday and learn more about MODSIM. But before we conclude the session, I want to learn what is MODSIM. So I do my Google, and Google say MODSIM is a data-driven, collaborative, and concurrent approach to product development. So in order to achieve that objective, data-driven, collaborative, concurrent design, the best tool that you can use is actually 3D experience. That's the common platform where you can share your data, where you can collaborate and publish the result and make your own decision on what would be your product. So come back to us, come back to see us on Friday at 11 o'clock to learn more about MODSIM and the promotion that you have for this Q2, Q3, and Q4 as well. All right, so with this, I can conclude the session, and we probably open a quick Q&A for you to ask us the question. Otherwise, we see you on Friday. So any questions so far? Or you want to keep the question for Friday?
I think let's keep the question for Friday.
keep the question for Friday,
for
because
Friday,
Friday
yes.
you're gonna learn more, and
Yeah.
then once you learn more, you will have more questions to ask. All right. So, ladies and gentlemen, I will see you on Friday, and hope you have a very good afternoon then. Bye. Come to see us on Friday for MODSIM.
Bye-bye.
Bye.
Bye.